This conference will now be recorded.
Hello.
Yeah, I hear. Yeah.
Oh, my bad. I was speaking on mute actually. Yeah. Yeah, no worries. So, Sin, as we discussed yesterday, right? So, we will be starting off with the SQL training initially, and then we will get into Snowflake and what exactly is Snowflake and all about. Okay.
Sure.
And one more question is you can install any database in your system, right? So, that is possible, right?
Any database mean
Yeah, I'll let
Oracle?
you know. Oracle or MySQL or anything.
Okay, so tell me the steps. I will download and yeah.
Yeah, sure. I'll give you all the details. You can download it so that you can start practicing it as well.
This session is recorded. Sometime I forget things. So
I think it is
Yeah, now
recorded,
the
right?
session is recording. Okay, once you're done with
Yeah.
the session, we'll share the session recordings to you. Okay.
okay, great. Thank you.
Yeah. So let's start off with the SQL training scene. Yeah.
Okay.
Yeah. So what we understood from yesterday's introduction, or what we got to know is you need databases, and you need go ahead and query those databases. Okay. So in order to get the data out of it. So you have a particular database. So let it be Oracle or MySQL or anything. Okay. And what happens is you need to generate a report. So as I told yesterday, you have SAP HANA. Okay. I'll just take that example. You need SAP HANA report, or you want to go ahead and create a SAP BO report. Or right now, what you can say is you have Tableau, you have Power BI from Microsoft. Okay, so if you want to go ahead and create these reports, you need to connect to this particular data. Okay, you need to query the data. So all your data is here. So whatever tables is there. So let's take a simple data set: employee, okay, department, and location. These are the tables that we have. So all these three tables are there inside the Oracle database. Now I need to connect from my Tableau Power BI to connect to this particular Oracle database, and I will create reports on top of my employee, department, and location table. Right. So in order to do that, what we need is we need a querying language. So to connect, I'll have all different kinds of connectors, or from the UI based, I can go ahead and connect it. But how do I query these tables? Okay, why do we query those tables? In order to access the data that is there inside the tables. So for that, we need a querying language, and that querying language is your structured query language. Okay, so what does your SQL stands for? Is your structured query language. Okay. So it's why we call that as a structured query languages. It has different kinds of steps. Okay, it is having all different syntaxes for each and every I can say manipulation or anything that you're doing in your SQL, and based on that, you can go ahead and query or access the data that is there inside your databases. Okay. say at any point of time stop me, okay, if I am going very deep or you know that concept, so I'll just skip that concept and move to a different concept which you don't know. Okay.
Okay, no problem.
Yeah. So the next thing that we will understand in the SQL is we got to know why we need SQL, right? So we are going to access the data that is there inside your database, and we also need SQL, okay, to insert the data into the database, okay, to update the data into the database. Okay, so there are a lot of uses that you will be doing it. So the next thing that we have is the data types. Okay, what is a data type in SQL? Okay, SQL is, and what is a data type is, it is nothing but how your data is stored. Okay, so for example, you have a table, as I told you, you have an employee table. So let me put the employee table here. Inside my employee table, I have employee name, employee salary, employee date of birth. These are my columns information. And inside my employee name, what I have is I have my employee names. These are the values. And this is my employee's salary. Okay. And this is the date of birth. So let's understand this. So if this is the date of birth like this, for example, to store this data inside the table, okay, when I am creating a table called employee with employee name as my column, what I need to do is I need to specify a data type for it. Now, what data type is telling is, it is telling the SQL query language or the database where you're running the SQL query language that the column that you are trying to insert or the column that the user is trying to create is of a string data type, is of a numeric data type. Okay, we are telling what kind of data it can store in that particular table or in that particular column. Okay, so that's your data type. So inside your SQL query or in your Oracle or MySQL, so there are a lot of data types that you can use. So for example, in Smith, if I go ahead and insert 300, will it take? It will take. Okay, if I go ahead and insert in e-salary, if I insert clerk, will it take? No. It will throw you an error saying this is a numeric column and you are inserting a string value. Okay, so this is your data type or why we use a particular data type. So for example, inside your SQL, you have binary data types. First one. So there are different types of data types. So the first one is your binary data type. Okay, where you are going to store, okay, binary information. This comes into a picture when you are dealing with your configurations or manufacturing or chips manufacturing or anywhere when you want to use your binary values, then you can go ahead and use your binary data type. Okay. Apart from that, you have something called as numeric data types. Okay, so what is numeric data type is, inside this you can use int, okay, you can use decimal. Okay, so what does int is? Int is nothing but integer. You can store your integer values. Okay, so your integer values are like, you don't have a decimal point when you're dealing with your integer values, like your e-salary, for example. So I have 3000. This is my integer value. If it comes to decimal, what happens is I can go ahead and give some decimal points and also digits after that. Okay, so that is like, for example, I can go ahead and give a price. Okay, so for example, if the price is 23.45, this is the decimal value. Okay. So if I want to store my data in this format, then in this like decimals, then I can use decimal. If I want to store only integers, I can use int. Okay, and then I can go ahead and create it. Okay, similarly, you have character data types. What does character data types do is they deal with the string data types. Okay, like string values. A string is nothing but which is having all mix of alphabetic, numeric, and all the different kinds of symbols also you can have, but that's a string value. So inside SQL, you have data type called char. Okay, or I can say we can put this under the string data types. In this, you have char and you have var char. Okay. Also, you have something called as text. Okay. In char, what you can do is the data is of fixed length. If you want to store data of fixed length in the string value, then you can go for char. Varchar and char are almost similar. Only thing is it is a variable length. Okay. Now, one more thing that we need to observe here is when you're defining a data type for a particular column, along with the data type, you will also give the a value of that particular column. That is nothing but, for example, I will say int of 8. Okay, this will be the salary column. In salary, int of 8. That is nothing but it can store integer values, and the length of the integer values will only be till 8. It should not exceed 8. Okay, this is how usually we define it. When we define char, you can give fixed length. Varchar, what it does is it is of variable length. That is nothing but depending upon your string, it will actually assign the memory at the back. Okay, so when you are defining a particular integer 8, right, so there is a memory allocated in the system or in the database or whenever you're trying to process it. This memory allocation, irrespective of the value that you have, it allocates 8 or 8 bytes, I can say. Even though you are inserting value of 2 length, okay, so for example, if your length is 1 2, okay, this is the value, or I have 49, this is the value. Irrespective of the length of your value, it will allocate 8 digits. So here what is happening is there is your memory is unnecessarily used, or there is a like even though the value is very small, you are even giving more space to it. So to overcome that, what they did is they came up with varchar for strings. For only this is only for strings because your string values are sometimes very big. Okay, so you'll have a big values inside your strings, and then if you want to use, or you can actually like it comes under your performance tuning also. So what you can do is you can provide varchar and it will create variable length. So if your string is of 6 digits, okay, it will give 6 as your value or memory space. If it's 8, it will take 8. If it is 124, it takes 124. So irrespective of the value, it is not giving the memory. Based on the values length only, it is going to go ahead and allocate the memory. So that's your varchar. The next thing is your text. The difference between your char, varchar and your text is nothing but text can actually hold a huge amount of data. Okay, so when do we go and define text data type is when you want to store data of, for example, comments. So you have YouTube comments and you have Facebook comments and everything, right? Sometimes these comments are very big. It's not one single word or two single words or two words actually. It's a very big statement that you usually give in the comments, okay, or in the feedback forms, okay, or I can say description. For example, you have a product description in Amazon. That description, right, it is stored in a particular text because it is very big. So when you want to store these kind of information, you can use your text data type. Okay, so clear till here, Zain? Any questions?
Go ahead. Yeah, it's good. No question.
Sure. Okay. Yeah. I'm just changing it.
I'm looking at these data types, right? So yeah, I'm just familiar with this one, these data types. Yeah.
Okay. If you're familiar, yeah, sure. Great. I'll just skip it because yeah,
No,
I
it's
don't know which well.
as for the SQL, I haven't learned SQL, but some of the data types is used in SAP, right? For the and
Yes,
also
yes, that's correct.
about programming, they use it. Yeah.
Okay, okay, okay. You worked on SAP ABAP?
I know a little bit of, but not like not fluent. I
Okay,
mean,
no issues. Okay, yeah. So it's great that you already know the concept of data type, but these are for from system to system, or I can say from database to database. Your data types might change. Okay, but these are the basic data types that you have. Okay, yeah. So let's start with the next page. The next data type that we have is the date time. So if you want to store any date and time information, so the previous example we have seen, right, where we want to store employees' date of birth. Okay, in that case, you can actually go ahead and use date time data type. Okay, in the same thing, you also have date, or if you want to store only date. Okay, or you can also use time if you want to store only time information. Okay, so these are all your basic data types inside your SQL. Okay, yeah. Let's get to the next part. So in SQL, what we have is we have four things. First one is your DDL. Second one is your DML. Third one is your TCL. Okay, and then fourth one is your DCL. Okay, so let's see what we will get as part of DDL, DML, your DCL, and your TCL. So
these are
as per mhm.
these are four different SQL.
No, these are parts. What you can do is, you can see them as a components of your SQL using these. So whatever you do in SQL, right, we are categorizing them into these.
Okay. Okay, good.
Okay. Yeah. So as part of your DDL, DDL is nothing but data definition language. Okay. So your data definition language is nothing but it is actually helping you to define the database structure. Okay, so we are talking about databases only, right, from past the 20 minutes or anything. So you have your database. For example, we represent database like this. Okay, so I have a Oracle database. You need to structure this database initially, right? That is nothing but you need to create multiple databases. You need to create schemas inside it. I will talk about it. We need to create tables. Then you need to insert the data. Then you need to update the data if any time needed. Okay, you might need to go ahead and select the data to view whatever is needed. So there are a lot of operations that you're doing on it. Before this, what you do is you need to create a table. That is nothing but you need to create a structure for the table. Then only you can insert it. Right? So the steps are, first you connect to the database. Okay. Then what you do is you connect to the respective schema. Then you go ahead and create it. Create a table. So what happens? A structure will be created. For example, it will be like employee name, employee number, and employee salary. The structure will be created, but there will not be any data inside it. After you create the structure, you will use insert statements to insert the data. Then you will have the data inside your table. Okay, so this is the usual process. So to understand this or to do this process, we are taking help of DDL. Okay, so DDL is for your defining your database structure. Okay, so in this what you do is you're going to go ahead and use create statement. Okay, so in create
Yeah, clear.
concept is you can create it. Okay, and there is another statement called alter. What does alter do is it is going to go ahead and alter your so after 6 months there is a use case wherein I need to add a new column to the existing table. Okay, in that case I go for alter.
Okay. I haven't. Because last, I mean, maybe 2 minutes, I couldn't hear you. It's like breaking out.
Oh, right now you are able to hear me, right?
Yeah, it's good now. Yeah.
Okay. Yeah, there
You,
was something, I think the record got stopped and it got started again. Yeah.
okay.
Yeah, I'll repeat it. So using DDL, what we are doing is whenever a particular statement is going to change the structure of the object inside your database, okay, that comes under your DDL. Like create. When you create, what happens? You're creating a structure. Alter. As alter, I said, right? Alter is nothing but, for example, you have a table and you want to add a new column to that particular table. In that case, you're changing the structure from 4 columns to it becomes 5 columns. So you're changing the structure. So then that comes under your DDL. So your alter command comes under your DDL. Similarly, you have called as drop. Okay, you have rename. So we will see all these things. We'll be executing all these things also. So in that case, then I'll get into the deeper details of this. So these are the statements which comes under your DDL. So these statements actually change the structure of your objects in the database. Okay. Now coming to your DML. DML is nothing but your data manipulation language. Okay, so we have used all the DDL statements and we have created table, we have altered the table, we have renamed and all those things we have done. Everything is good. Now how about the data? I don't need only the structure, I need the data, right? So I need the employee data. What I'll do with the structure? So in order to insert or you need to have data inside your table, what you do is you take off DML statements. Take help of DML statements. So what are the DML statements that you have is insert, to insert your data. Update. Okay. So to update your particular data. Delete. So at any point of time, if you want to delete a record, okay, that is your delete statement. Okay. Similarly, you have select. Okay. So these all comes under your DML operations. So we call them operations because you're inserting, updating, deleting, and selecting. The next thing that we have is your TCL. What is TCL is? In TCL, you have something called as commit. You have rollback. Okay. So let's get to the details here. So I'll let you know what it is now. Yeah. So what happens when you're working on a particular SQL or using your databases is, okay, so you go ahead and create or run multiple statements, right? So for example, first statement I have run is create table. Okay, so after this, what did I do is I inserted a record. Also insert row 1. So how does your table look? It looks like this, right? So it's a table is nothing but you have columns and you have multiple rows. This is your table. So when I created the table, this is the table structure it got created. 1, 2, 3, 4. These are the columns. Okay, now I've inserted one row. Okay, then I used the insert statement and inserted my second row. Similarly, I inserted third row. Okay, then what I did is I deleted my row 1. I have updated my row 2. Okay, so these are the series of actions that I am doing or operations that I am performing on a particular table. Okay, during these things, what happens is in the database, how they have designed it is, whenever you go ahead and insert a particular row, right? So there can be some issues, or there can be some lag, or there can be some I can say blockers. Okay, and then the data might not have inserted, or there might be some scenarios wherein you have inserted a wrong data. Okay, this is something, this scenario I'm talking when you have millions of records. Can you just give me a second? I'm just getting a call. Just sorry for that. Yep. So in this particular scenario, when you have millions of records that are getting inserted, so for let's take an Amazon website example only. Okay. So daily, how many number of transactions happens? So there are millions of transactions that are going to happen on a particular day. Okay. In this transactions also, you'll have different kinds of transactions. It's not only a similar transaction that happens every day. So there are people who are placing orders. There are people who are requesting for returns. Okay, so there are people who are just going through all the browsing and then they're just stopping it. There are people who are just adding it to the cart. Okay, so lot of transactions. There is something that is going at the back end where they are tracking the delivery. There is something that they're going transactions that are at the back end that is happening where they are dealing with the merchants actually. So from the Amazon website, not only with the customers, they are also dealing with the merchants and they are generating the invoices, right? So a lot of things that happens on a particular day. So these all things data, right? So whatever the data that is happening, everything will be inserted as records inside the table in the database that they have created for their application. So at any point of time, okay, they need to go back or they don't want that particular data to be inserted. Okay, they can go ahead and use rollback. Okay, so for example, I have inserted 3 rows or I've done these 4 operations. Okay, and what happened is I just there is a commit statement. Okay, I executed a commit statement. Now what is commit statement is, it is going to create a checkpoint inside your database transactions. Okay, it says this particular transaction, okay, from till this commit point, whatever the data is inserted, it cannot be removed with a rollback. It can be removed only with executing statements like delete or drop or these kind of statements. Okay, but you cannot remove those records with a rollback statement. But what does rollback? After this particular commit, there is a statement here, that is your update row 2. Okay, and I did not execute commit. What happens is, if I execute rollback, it will actually go back to the previous states to the last commit. So this is the last commit, right? So it will get back to the previous state from here. Okay, this the best example for this or the scenario for this is, for example, I am loading millions of records into a table. It takes around 2 hours. Okay, so what happens is, when I'm loading these millions of records at after 1 hour, okay, it got stopped. Okay, the loading got stopped. That is because of some or the other issue. The server is down, okay, due to network, okay, or the data is not being processed correctly or anything. Okay, in this 1 hour, there is, like, for example, 1 lakh records that got inserted. There are more records that needs to be inserted also. Okay, so what I need to do is, I can not go ahead and run the load again, and I cannot insert the data again, right? You cannot have duplicate records inside your table. So what we do is, we do a rollback first. So when you do a rollback, what happens is, it goes to the last previous commit state, which is your safe state. Okay, you can call it as a safe state. So it goes back to that state and it sees where it has actually stopped the loading. From there, it will start the loading again. Okay, that's your rollback. You're clear with your commit and rollback, right? Same.
Yeah, makes sense.
Okay, so here what happens is, when you're using a DML statement, you need to use the commit. Okay, that is a mandatory thing, because if you don't use commit, what happens is, at any point of time, if you are out of that particular session, or if you close your window that you're working on, all the changes will be rolled back. Okay, there you cannot see the data. If you want your data to be changed inside the table using a DML statement, you need to use a commit. Okay, this is a mandatory step. So whenever you're using a DML statement, you need to use a commit If you don't use it, your data will be rolled back to the previous commit. Fine. But for DDL statement, you need not use it. Okay, you already have create, alter, drop, rename and these DDL statements, right? You need not use a commit, because DDL, when you execute a DDL, it automatically executes its own commit. Inbuilt there is a commit, it executes it. Okay, so this is about your TCL. Okay, what is TCL? TCL is your transaction control language. Okay, the next thing is your data control language. So now what is the DCL? Okay, in DCL what we have is, we have two things. One is your grant and revoke. Okay, so I have my database, I have created the tables and everything. Okay, that is pretty good. Okay, now I need this table. If I only access this table, that is not a good scenario, right? I created the table and I'm only accessing it. So if I'm doing some development or some POC, then that is fine. But in your real-time applications, for example in Amazon only, if the Amazon company has created orders table and it is not giving access to anybody, then does it make sense? It doesn't make any sense, right? So everybody should have access to the table, or at least the users who is having permission should have access to that particular table. Okay, so that you can provide the access using your grant and revoke. Okay, using grant, what you can do is, you can actually allow specified users to perform a specified task. For example, I can go ahead and say grant user or grant select on user 1. So what happens is, the user 1 will only have permission to select the data from the table. Okay, similarly I can give select / insert on user 1. So he will only be able to select and insert. He cannot update or he cannot delete. Okay, so depending upon the users, we go and give this access. I cannot give grant all on the particular user 1. Until and unless the user knows about the system, I cannot give grant all, because he'll have permission to delete, he'll have permission to drop, he'll have permission to select, insert, update, everything. So by mistake, if he has done something, there is a change in the data and it will actually hinder the process, right? So what I do is, I give, depending upon the user who is using it and based on the role they have, we will be giving them the grant access. And revoke is pretty simple. You have given the access, and some certain point of time you just want to remove the access, that you can go ahead and revoke it. Okay, so you're clear with all the 4 things, right? So DDL, DML, TCL and your DCL. Any questions in on this?
I'm good, thank you.
Okay, so let's get to the next concept. Okay, so as we are already seeing the DDL, DCL and DML, let's see how do we go ahead and use the statements inside it. Okay, so for every statement inside SQL, you have something called as a syntax. Okay, now what is syntax? Syntax is nothing but, it is a predefined way, okay, on how to use a particular statement. Okay, if I say create database, I cannot write it in my own language saying SQL go ahead and create database. Okay, there is a language or there is a statement for it, right? So that's your syntax. So for each and every statement that you're using, you have a particular syntax. So when we talk about the DDL language, so we will be talking about the create statement first. Okay, the first statement is create. So using this particular statement, you can go ahead and create, or you can use create statement and create databases, create tables and everything. Okay, so first let's start with creating a particular database. So DB is your database, and if I want to create a database inside my SQL, what I can do is I'll use the syntax create database, and you need to give the database name. Okay, here this will not change at any point of time. Your create database will not change. Your database name will change. Okay, if I want to create a database called Superstore. Okay, this is my database name. I can create like this. So now when I create this database Superstore, what happens is at the backend, your Oracle or your SQL or sorry, your Oracle or your MySQL or your SQL Server, right? Any of the databases, what they do is they start allocating some memory to this database. And inside this database, you can actually create tables. Okay. Now, when you see the hierarchy is like this. You have database. Inside database, you're going to go ahead and create schemas. Okay. What is a schema is in one particular database, you can have multiple schemas. Okay, that is nothing but I wanted to create different kinds of schemas, and all those schemas will come under one database. Okay, for example, let's take Amazon example only. Okay, so in Amazon database, for example, they'll have a schema for orders and returns. Okay, where they'll have tables related to orders, returns, and all this data inside the details inside that particular schema. Okay, and for example they have an another department, okay, where they wanted to deal with finance. Okay, so finance is nothing but they will be dealing with all the transactions, they'll be dealing with the particular refunds. Okay, all this kind of things they'll go ahead and deal with. That department will have an another schema. Okay, or I can take a very best example is in a particular IT sector. Okay, or in an IT company you have multiple sectors. So for the first thing is your HR. Okay, you have finance. Okay, and you have employee, or I can say other details related to your particular company. Okay, so I'll just put it as employee here, and this is your IT company. So for in this particular IT company, everybody they'll have only one database, they'll not have multiple databases, right? So there is only one centralized location where your data is getting stored. For each and every department, they'll have different schemas. They'll have a HR schema, they'll have a finance schema, and they'll have a employee schema, for example. Inside HR department schema, they'll have multiple tables. Okay, like for example, in this HR, you'll have timesheet. Okay, if you're filling a particular timesheet, every week you fill a timesheet, right? That you're going to punch in your hours for worked hours. So in that case, you can use the timesheet table. Okay, you have leaves. Okay, a particular employee is taking leaves and everything, that particular things also stores gets inside your HR leaves. Okay, and apart from this there are a lot of things. Okay, for example, your salaries. Okay, all those details will be there with the HR, right? And the next thing is your finance. When you come to finance, there will be details related to your salaries and also related to your taxes. Okay, So a particular finance department will generate your salary slip and everything, and this particular department will be dealing connecting to HR. HR will approve your salary, and then you will be getting all your salaries at the month end, right? So what happens is different tables are there for each and every thing that we do in a particular IT sector, and all those things are divided into different schemas, and each and every schema will have a, you can have multiple schemas, and you can, in each and every schema you can have multiple tables, and each and every table you can have multiple records. Okay, this is the structure of your database, how it looks, or how you can actually structure your database. So when I create a database superstore, what happens is it is allowing me to create schemas as well. Okay, you can go ahead and create schemas, you can go ahead and create tables. Okay. Now if I want to go ahead and create table, so why do I need to create a table? If I need to insert data or access data from a table, then I need to have a table there, right? So here what happens is we are going to use the syntax for creating table. Okay. Create table, table name, okay, you can open a bracket and you can actually close it at any point of time and use a semicolon. So any statement inside your SQL ends with a semicolon. Okay, here you can give the column information. Okay. Column name, for example, column 1, data type, okay, and the size. Okay, and this is not a semicolon, you need to use a comma. That is the syntax that they're giving. Okay, column 2, data type and size. Now when I execute this statement, what happens is it is going to create a table called table name, and it is going to give me two columns, column 1 and column 2. Okay, and the data type whatever I have mentioned, and also the size based on whatever the details that I have given. So for example, if I go ahead and create a table like this, so create table students, okay, and I'm creating roll number, and it's of integer 3, and I have a student name where I'll use varchar of 20, and for example the course that they are into, okay, course, and it's of varchar 20. So it's the last column, so I'll not give a comma here, and then I'm going to close the brackets and give a semicolon. Now when I run this particular statement, it goes ahead and creates a students table, and inside students table you will be having roll number, name and course. Okay, so here you can store integer values, here you can store varchar values, that is your character values, and here in your course you can go ahead and store your varchar values. Okay, clear on this end?
Yeah, it's good.
Okay, now let's get to the next concept. So now once we have created the table, okay, and we have used a create database and all these details, right? So let's see how we are going to go ahead and insert the table or insert the data inside a particular table. Okay, okay, before that let's see this as well. So along with the statement we will also see drop and truncate. So let's talk about drop first. Okay. So what does drop do is, you have created a table, okay, and you want to remove the table from the database. Then you can go for your drop. Or you can also go ahead and delete a particular table. Okay, in that case, you can use your drop. Okay, so when you use a drop, what happens is, it is going to delete the data inside the table and also the structure. That is, you not have the data, the table only inside that particular database. The structure will also be deleted. And when you try to access the table again, right, it will throw an error that the table or object you are looking for is not existing. Okay, so the syntax for this drop statement is, you drop table and table name. For example, students. I have created a students table, right? So I'll put drop table students. And if I execute this, what happens? It is going to drop that particular table and I'll not be able to access the table at all. Okay. Now, there is a scenario wherein I want to have the structure, but I want to remove the data. I don't want the records, because I just want to remove the records and I want to load it again. In that case, what I use is, I use truncate. Okay, so truncate is, it is going to delete the data. It is not going to talk about or think about any of your structures. Okay, it is only going to go ahead and see the data or delete the data from a particular table. Okay, so for this, what is the syntax is for truncating a table? Truncate table name. So I'll say students. So what does it do? It will delete all the data, but the structure will be available. Okay, that's all about your truncate and your delete. Any questions in?
It's good. I understand the concept. Yeah.
Okay,
Thank
great.
you.
Yeah. So yeah, initially I'm going a bit slow. Okay, then we'll get into the faster pace and when we'll start off the hands-on. Okay.
Sure.
So let's get
I
into the. Mhm.
I find this is right speed you are going.
Okay.
Yeah.
Sure. Yeah. So let's get into the next thing, that is your DML statements. Okay. So we have seen the DDL now, right? So the DDL is your create statement, your drop, and your truncate. Now we will talk about the DML statement. So the DML statements, what we have is, we have the first one is your insert. Okay. So for writing a particular insert statement, why are we writing an insert statement? To insert the data into your table. Okay. So what happens is, at one particular point of time in SQL, you can only write one insert statement. Okay. So I can go ahead and say insert into table. Table is your, for example, students. I'll open it. I'll give the column names. What is my column name? Student or roll number, name, and course. And the syntax is values. Okay, and give the value here. what value you want to give. For example, roll number 32, name Smith, okay, course BI or business intelligence, and I'll use a semicolon. This is how I write it. So what is the syntax now? Based on this, how I can write the syntax? So insert into table name, column 1, column 2, and so on. What number of columns you want, values, give the values here, value 1, value 2, and so on. This is the syntax. And if you see, when I'm giving the values, if it's an integer, I'm not giving quotes. If it's a character, then I'm giving a quote. That is how you need to define it. If you want to access any integer values, you need not give any quotes there. But if you want to access your string values, then you need to give quotes, and then only it will be able to understand that it's a string value. Okay. So after I do this insert statement and I run a select star from students. So this is your select statement. Now what happens when I run this query? It will show me all the records that is there in the students table. Okay. So this is about your insert. How you go ahead and insert your data. Okay. The next thing that we have is an update. So let's see what is an update statement inside SQL. Here, what is update? Okay, so when do we use update? So we have inserted the data, which is well and good, right? So I want to use update. So why do we use update? Is you want to update an existing record. So there is an already a record. For example, if you see the students database only, or students table, sorry, example, students table. Okay, in this particular table, what you have is you have student roll number, student name, and students course. Okay, so for example, I have 32, I have Smith, and the course that I've given is BI. Okay, now what happened is I wanted to change, or there is a spelling mistake in the particular student's name, so I want to update it. I cannot insert another record, right? It's a duplicate record. You cannot have two roll numbers same in a particular table for a student, right? So what happens is I need to update the existing record here. So in that case, I can use my update statement. So the syntax for update is update table, okay, whatever table that you want to update, okay, set what values you want to change or update, column 1, which column you want to change, and what is the value or expression that you want to give. Want to change column 2, and what is the expression that you want to give. Okay, and then you can give a semicolon. Okay, so there are a lot of different ways also that you can use and update it, but this should be good. So for example, I can go ahead and say, so I want to give it, this is Smith, right? So I want to update that value to K Smith. Okay, now how do I update it? First I'll write update. Okay, this is good. And which table I need to update? I need to update students table. Okay, and the next syntax is set. Which column I want to update? I want to update the name column, right? Name is equals to, with what name I want to update? I want to update with K Smith. Now if I execute this statement, you can understand. If you execute this statement, what it does, all the values that are there inside the students table within the name column will be updated, right? So because we are not saying update this record, there might be some other records also. So there are a lot of records. What I want to do is I only want to update this particular record. Okay. So in that case, if I write this statement, update student set name is equals to K-Smith, what happens? It will update all the values, and that is wrong. So what I do is I use a condition here now. How I can use a condition is I can use a where clause. So inside SQL, you have a clause called where. Where clause is something where you can go ahead and give conditions and it will filter your records. Okay. Update student set name is equals to K-Smith where roll number. So based on roll number, I'm going to select it because your roll number is unique value to identify that particular record. So where roll number is equals to 32. So what does your SQL do is first it will see students table is there or not. Then it will check for where roll number is equals to 32. Okay. If you have this particular roll number, then what does it happen is it goes and picks this particular record. From this particular record, what happens is it is going to update this name Smith to K Smith. Okay. Then it will update here and you will be able to see K Smith in this particular table. Okay. This is clear, right? Why we are using the update and how we are using it.
Sure. Yeah.
Yeah. Okay. So I'll stop the session here today, Sane. Okay. So tomorrow we'll be connecting and we'll be seeing all the other things that we have like grant, revoke, what is the syntaxes and all those things. And we'll be getting into normalization and more details about the SQL concepts. Okay.
Cool. Thank you.
Yeah.
So I will get this recording session.
Yes, you will get it.
Okay, great.
Yeah. You can go through it and I'll also be providing you the material after 1 or 2 days. Okay. Probably from Tuesday, I'll be providing you the material and you can even start looking into it and then start practicing it.
Okay. That's good.
Okay. Yeah. And on Tuesday, we'll talk about what database to install and how we will install for practice as well.
Yeah, sounds good. Thank you.
Yeah. Thanks, Ian. Thank you.
Okay, thank you. Bye.
Bye-bye.